On this video I'll show you how to perform neurofeedback training in neuronspectrum.net software. I start the software with default settings. In the left side of start page you can see fast commands, for example such as new examination, open existing examination, montage editor and so on. And here in bottom part you can see predefined templates for different type of examination. For example, routine EEG, video EEG monitoring, evoked potentials, cerebral function monitoring, polysomnography, and also neurofeedback. To perform neurofeedback training, we will start this type of examination. I press the button and start new exam. I'll put the patient name, sex and other data which is necessary for my training and press OK button. Now I have no device connected to my PC, so we will try to work in emulation mode. Emulation mode is switched on automatically. You can see it here. And here is our traces area. From the left side you can see a list of derivations which are included in our current montage. It's 8 monopolar EEG channels and 1 ECG channel. On the top part under the traces we can see neurofeedback training successfulness trend. Now it is empty because we didn't start any training. And on the right side you can see neurofeedback manager window where the operator or doctor can manage training process. Here, for example, you can select neurofeedback template. In this list you can see a list of predefined templates and you can add your own template. Each template contains several or one training conditions. For example, we'll select relax training, which contain 3 different training conditions. The first one is rhythm index, which asks to a rhythm index of alpha rhythm to be from 20 up to 100%. It means that according to this condition, alpha rhythm of EEG recorded from the patient should be more than 20%. Also here we can select another rhythms if it is necessary, or just select custom frequency band and set frequencies here. And also we can change the interval of index here, both before training and during the training also. One more point, that here we can select the derivations on which these calculations will be done. For example, we can select only occipital derivations for alpha rhythm. Or we can select none derivations, and in this case all visible EEG derivations will be used for calculation this parameter. Second condition is ECG head rate, which should be from 50 up to 70 beats per minute. And the third condition is breath rate, which here need to be in this diapason also. And using this button, add condition, we can add any other conditions in our current template. For example, we can add EEG rhythm index level like this, ratio between different EEG rhythm indexes, head rate, respiratory rate, galvanic skin response amplitude, EMG amplitude and EEG amplitude. I'll show you, for example, here according to this template, our EEG amplitude should be less than 100 microvolts. Also we can select the derivation for this for this condition. Also we can use, for example, oxygen saturation level condition, temperature of the body, EEG amplitude in selected frequency range, something like this. We can select the duration, for example, central durations. We can select the frequency band for calculation, for example, like this. And we can set the interval for amplitude of this EEG amplitude in this frequency band for this duration, less than 100 microvolts. Or, for example, we can put another interval here. Okay, we create our neurofeedback template, which now contains 5 different training conditions, and our successfulness will be calculated as a mean between all these conditions, mean value. Also here we can select the feedback view type for the patient. First of all, we can switch on a patient window. Actually, as you know, neurofeedback training is performed with a second monitor for the patient. First monitor will be used by doctor or by operator, and the second monitor is used by patient for view feedback here. But now I have only one screen, and that's why software show me patient monitor here in this window. If we will have the second display, the software will automatically show this picture on the patient display. And here we can select a different type of feedback type. It can be different games, multimedia information, something like this. And also it can be, for example, some slideshow or video film which you can select from your computer. For example, for slideshow I can upload several photos. This is my family photos, and software will show these photos, and the quality of photos will be depend on the successfulness of training. If patient successfulness is good, the photos will be shows very clear. If successfulness is not so good, the clearness will be less for the photos. Or we can use puzzle slideshow, when the photo will be closed with these blocks, and these blocks will be hide while the successfulness will be better. To demonstrate this, let's start our training. I'll select the first feedback type, goldfish. It's just a little game for the patient. When we start training with this button, first of all, software asked us to check the impedance and to be sure that all electrodes are placed correct and impedance is good. We remember that we are working in emulation mode, that's why we have no impedance here. Now EEG recording is started, and we can see instruction for the patient that speed of moving of this fish will be increased if the successfulness will be better. For example, now you can see the software start epileptiform emulation, and during this emulation alpha rhythm is lower, and now it is back to normal signal and alpha rhythm is higher, and you can see the successfulness of first condition is about 100%, but now it is also emulation mode, emulation epileptiform activity, and successfulness is very low, only 5%. Now back normal EEG, and successfulness is growing up to 100%. In each condition you can see the current values for each parameter. For example, here is 18% alpha rhythm for now, and our limit is 14. We can increase it to make this task more difficult for this patient, and you can see that successfulness is lower. Now it is again epileptiform activity emulation. It is clearly visible here in trend, successfulness trend, and you can see that current value of algorithm index is about 20. We can make this condition more difficult for this patient. As for other conditions, for example, we can switch all of them, and now it's only one condition working for this template, and our successfulness is calculated as the same successfulness for the first condition. When we add other conditions, the common successfulness is calculated as a mean value between these two conditions, or between all other switched on conditions. Unfortunately, we have no ECG signal, and heart rate calculated not so good here, and successfulness is about 0. We can switch it off. What about breath rate? Also, we have no breath signal in our current montage, and the successfulness is 0 here. We will switch it off, and EEG amplitude in O1 duration is less than 100 microvolts, and the successfulness is 100% here. We can also make this condition more difficult, and you can see that successfulness is lower. And what about EEG amplitude for central durations in this frequency band? It's about now it's emulation of epileptiform activity and high amplitude and 0 successfulness. Now it is normal signal, and we can see that it's about 60% of successfulness, because current parameter is not in this interval. We can make this task easier, and now you can see that successfulness is 100% for this condition. We can show successfulness to the patient in digit value, like here. Let's wait while EEG will go back. Yes, now it is final successfulness calculated by all switched on conditions. Or we can show it as a bar for each condition, separate bar for each condition. You can see that the first condition successfulness is lowest, and the last is the highest. It means that first condition is more difficult for the patient, and we can make it easy changing this value. Now you can see that it is successfulness on this condition is higher. What about other view? For example, octopus. It's very easy feedback type, when octopus swimming higher if the successfulness is good, and swimming lower if successfulness is not so good. It's very clear to understand and very easy to move it. Here is some cars game, when the speed of the car depends on successfulness of training conditions. And as I told, we can use slideshow or video film demonstration for the patient, using, for example, some family pictures. Here is the puzzled slideshow. When the puzzle is clear, when the successfulness is good, blocks are hiding very fast. If successfulness not so good, blocks are hiding with a low velocity. So during training, neurofeedback training, we can also make some pause to give some rest for our patient. For example, we can stop our training. We can see it as a marker on the traces, and we also will see it on the successfulness trend a little bit later. Then we can select, for example, another neurofeedback template and continue our training. As you can see, we can do it manually, like I already showed you, or we also can do it automatically using this panel in the bottom part of the window, where you can see now 3 different tests. Each of these tests connected with predefined neurofeedback template, and also each of these tests has a predefined duration. So when you start, for example, alpha theta training, corresponding neurofeedback template is switching on automatically, and this training will goes about, I don't remember, about for example 10 minutes. And here you will see the progress bar directly on this button. You can see it now start here with the dark blue color. And using automatic functional test button, you can start all these predefined tests automatically, one by one. Also, between these tests, you can add functional tests with no neurofeedback template, and it will be some rest for the patient, like a pause between different sessions of our training. So, using this tool, we can make a very difficult template with several sessions, which will be recorded in automatical mode. I'll show you how we can set up it in program settings. So now let's stop our training. I'll close patient window just to show you how we can review already recorded EEG and other data. Here you can see we can move recorded EEG data with mouse wheel, with a navigation tool, and you can see that in right side in Neurofeedback Manager window we can see the current values of recorded parameters, the current successfulness of each template, and switched of each template condition. For example, here we changed the neurofeedback template to alpha training. Here it was also alpha training, and here it was relaxed training. Here it was alpha theta training, and we can see also the current parameters and current successfulness during this time. Also, successfulness we can see here on neurofeedback successfulness trend. We can move and check why, for example, here it is 0 successfulness because it is no template was selected here. And for example, here we can see that the signal of EEG is according to this condition, it's not so good. And successfulness is very low here. It's normal here, but it is low here because change of EEG signal. So a few words about settings. I showed you how we can set up neurofeedback templates and conditions here directly during a new examination, but actually we can predefine our necessary templates and scripts before training with this patient. To do this, we can use settings, edit, and use our acquisition style settings. Now it is neurofeedback style, acquisition style, and here in neurofeedback page we can see our list of predefined neurofeedback templates, and here we can add our new neurofeedback template. We can put the name, and then we can add the necessary conditions for this template. Actually, usually these conditions are selected individually for each patient according to his disorder. For example, we can add EEG amplitude in selected frequency range, for example, for occipital durations. We need to increase, for example, some diapason close to alpha rhythm, for example, these frequencies. We can increase amplitude for example, more than 100 microvolts, something like this. Also here we can predefine the feedback type, for example, slideshow, and we can upload the pictures for this patient, or we can for example select video, film, and upload some video file. Unfortunately here I have no video on this computer. Upload some video which will be interesting for this patient, and also we can set up showing results of training in person or in as bar chart. Okay, let's save this like this, and on page functional tests we can add the special tests which will be start our neurofeedback templates automatically. Here you can see 3 predefined functional tests. For example, we don't need several of them, but we can add our own functional test. We can put the name here, and we can select the neurofeedback template here. For example, our new neurofeedback template. You can see it here. So in this script there will be alpha training. The duration is 20 minutes here, and then we'll start new functional test. Duration is 60 seconds. We can add, for example, we can do it for example 10 minutes like this, 600 seconds. Okay, we will save this acquisition style, and after that, when we will start new template, new training, neurofeedback training for our new patient, we can get we will get our new templates here, and we can use automatic recording for start and perform this training in automatical mode. You can see now alpha training was started automatically, and here you can see the progress bar. Manually you can change it, for example, and start new test, new functional test after that, and so as I show, you can create very difficult scripts of different neurofeedback trainings for your patient. It's quite flexible mechanism where you can set up any parameters, as before acquisition, before training, both during, and you can review it after training. Here you can see the progress bar of current test, and here on this button you can see the progress bar of all script, including all your selected test. Okay, let's stop our training, and also we can create a report just pressing this button. A report will be generated automatically according to predefined report template data. Report includes patient data, acquisition settings, and results of training as a trend. So I think it's all